Hello everyone, today we will be doing discrete calculation. So our first one, let's check set operation. So to do this, we have to first import the library. We'll be using Sympy symbolic library to do mathematical operations, just different from CPy, NumPy. Those other one uses numerical methods for doing the calculation. So you'll be using Sympy for symbolic calculation. It's actually more better actually. To do this, let's import the library from Sympy imports. If you use star for example, you actually importing all the say class that is there. But here we want to use for set operations, so that you also know you can use finite sets. So this is the class we are importing from Sympy. After that, we define the equation. A is equals to finite set open brackets 1 2 3 4. Yeah, what's 2 3 4, no 3 4. Then B, finite sets it's 3, 4, 5, 6. Now after this, you use them. In set operations, you can be asked to solve for union, for intersection, for difference. So let's check union first. For union, assuming you were solving for union for this set, you have to do union equals A dot union open bracket B. Then for intersection, and that's the spelling, right? Okay. For intersection, you do A dot intersection A dot intersection open bracket B. Then for difference, you can be asked to solve for difference in some set operations. So we can do difference open equals to A minus B. Now we actually done, but to check it, in order to run the code, we have to use print union. How was it spelled? It was small letter. Alright, not just union, let's just print them, all of them. Also, let's print the intersection. And let's also print the difference. Alright, I think that's all for now. Let's run it and see whether we have any error. Wow, we have error. Error is saying here line 1 cannot import finite sets. You see, we actually have an error, cannot import finite sets. Why? If you recall, we ran the code and we were being told that it cannot import finite sets. The reason was because I wrote it with small letter. So from Sympy, import finite set, the F should be in capital letter. So let's run it again. It's still saying the same thing. Let's check. Alright, the finite set was not spelled correctly. The S is actually small letter, so we make it capital letter, Let's try it again. Now I have problem with line 3. Name finite set is not defined. Do you mean finite set? Alright, let's check that. Alright, it was complaining because of when I was defining that A, the finite set was actually in small letter. So I've corrected that. Let's try again. Alright, successful. So here is the answer. The first one is for the union. The second one, 3 and 4, is for the intersection, while 1 and 2 is for the difference. That's the answer for that set operation. We want to solve combination and permutation. For example, here is a problem we want to solve. A class has 10 students. How many ways can a teacher choose 3 students to form a group? That's combination question. The second one is, how many ways can the teacher arrange 3 students in a row? That is permutation question. So let's check it out with Sympy Python. Alright, quickly let's check this one so that we won't waste much time. First of all, to deal with that question, we have to import the library. We are using Sympy library, but we have to import the class that we will use. So we say from Sympy import factorial that's the spelling, right? Yeah. And binomial. Alright, now the number of students in the class was 10, so n is equals 10, remember? And they want to be arranged, it was 3, so we say r equals 3. So now we are looking at the combination for it. C equal binomial open brackets n comma r. Then for the permutation, since we are looking for the permutation for that, we go for factorial open bracket n double bracket n, the second bracket closes that, then all over factorial open bracket n minus r. That's just formula, right, to do that. So I need another bracket to close it. Good. So now we can print C to see what is it, the answer. Hope it's correct. Then we can print P also at once. So we run the code at once. Alright, let's run the code. The combination is 120 and the permutation is 720. So if you use this, you can actually solve for combination and permutation of a given class equation. Alright, see you in the next one. We'll be solving Boolean algebra. The question here is a security system is designed with the following logic. 1. The alarm will trigger if sensor A and sensor B are both active. 2. Alternatively, the alarm will also trigger if sensor A is inactive but sensor C is active. Simplify the logic expression to its simplest form to understand the core condition for the alarm to trigger. So let's get to it. In order to solve our Boolean algebra question, we will import the following library, is it class or module from Sympy. From Sympy library, from Sympy import symbol, comma, and, comma, or, comma, not, comma, simplify logic, simplify underscore logic. Alright, that's that for that. Remember I told you before that if you write from Sympy import star, that it will still do the same thing, right? Yeah. My idea was simplify underscore logic. I'm just writing this one so that you know which class is actually working on those stuffs. Okay. Now, the first thing to do is to define the sensors as Boolean variable. Alright, so to do this, we will say A, comma, B, comma, C equals symbols, open, A, B, C. I think that for that. Now, after this, we have to define the alarm condition based on the equation. To do this, you remember the condition. I will state it again when I'm doing this, and you have to pay attention here so that you understand how to apply these in other Boolean equation that you are solving. The equation was if this thing work with A and B. So to define this, we do an is an A, comma, B. What that means is that both of these like this alarm should come up if A is active or B is active. That they should come up if both of them is active. So that's it. That's why you are using and. It requires both of them. Alright. After that one, we see, I can delete that for now after I'll put it. We see another condition. Another condition, if you remember from the equation, another condition was that the alarm should come up if A is not active. So we use not A, and also if A is not active and C is active. So this is the last condition. The alarm had two conditions. The first one was A sensor is active and B sensor is active, turn on. And the second condition was A is inactive but C is active, turn on. So that's how we express this expression, and since it is two, we are using or. That's why you have the or at the beginning of the expression. After now, we will simplify the Boolean expression using the simplified logic. Alright, so here I can just write simplify You can actually name it anything you want to name. Let's just use this so that it will be more easy to read, Simplify expression equals simplify underscore logic open brackets expression. Alright, so now we are done. Just to print it and see that when you run the code, you check the output how it is. So we now say print expression. Apart from this guy, let's also print the simplified expression too. So print open bracket simplify underscore expression. I use simplify here, no? Should not use simplify here. It will not clash with what you are calling from Python. Alright, it should be simplified expression is equal to simplify underscore logic open bracket expression. So alright, let's run the code and see. We have error in line 1. Alright, let's check it. It's saying cannot import name simplify logic. Alright, let's check. The error we had was because this S was in capital letter, simplify logic. It should not be, it should be small letter. Alright, so let's run the code. We have error in line 4. The error in line 4 is because the S in the simplify logic is in capital letter and it's not defined. So let's change it to small letter. Line 4. Alright, so let's run the code again. Alright, and it's successful. I say A and B dash slash open bracket C and that A. So this is actually the answer for that problem. With this you actually learn you have learned already. You know how to define. First of all, you have to define the sensors as Boolean variables, and you have to be able to define the condition of the Boolean variable as is it going to be and, not, or. So you should be somehow convenient working with them Boolean variables, Alright, see you next one. Well, here we'll be solving modular arithmetic. Have you heard of modular arithmetic before? Maybe that will be a separate video, but here is a question of modular arithmetic. One of the examples look like this. It says a clock shows hours in 12-hour format. If it is currently 7 o'clock and a bell chimes every 3 hours, after how many chimes will the clock again show 7 o'clock? So let's get to it. Alright, to solve that problem of modular equation, as usual, from Sympy, import. Remember, I've been telling you guys that if you use juster, that it will still be the same, right? So let's use it and see. that's that you're just importing everything that has to do with Sympy. So sometimes if you don't really know which module, which class, what you are going to use under the Sympy, just use the star and you'll be good. All right, so now let's define the symbols. X is equals to symbol bracket x. All right, after that you have to define the mode of the equation. So this you can just write mode EQA equation. But one thing about Python, even though this we are just writing it for readability. Now, even though I write M E, or mode underscore E, just that, it will still run. Yes. So, but we just write these things, the way Python is, it makes it easier for someone to read the code. So that mode E is standing for modular equation. All right. So now to define this equation, we have to use this sign here. Yes, that's the sign you will use, and use that sign when you are solving for modular equation. All right. Solution. Now, writing solution here, as I told you, Python gives you the chance to name. I can just shorten it to solve. That is standing for solution. All right. Solve, open bracket, I name it mode underscore E. That's my modular equation, comma, X. And Python, whether you space or you don't space, it still understands it, right? Okay, print solution. I will not write solution, it will give me error because I define it as sol. So to print this successfully, it will be print sol. Well, let's run. I have error. The error I'm having here seems, where will I even begin from? Okay. Now, if you remember the last code we were trying to run, we had an error trying to solve that equation. It was actually because currently, I don't know, but I don't know the library yet that has the ability to solve that equation with Python. But however, this other code is still able to solve it, but it's a bit tricky. It's a bit tricky. So this one is saying, I already copied the code to paste it here after I did a little research on it. So in order to just make it easier, so that we just end the video, we say from Sympy import symbol solve. They define a symbolic variable for the number of times. That one is what they say total times pass will be the number of the times multiplied by the interval. So number of times times interval was 3. So leaving all this, this says equation is equals to total time pass minus 12 times symbol k integer true positive true. Solution equals solve equation, comma, num times. Now here is the logic of the code. If solution smallest num times equals solution 0, sub symbol k, comma 1, print the clock will again show 7 o'clock after smallest number times. Print no solution found. So this looking at this code, you can easily know that it's, though it runs successfully, but it's a kind of so much logic behind it to make it work. So I will after this video I will continue to check if there is actually a library that will be able to handle this modular arithmetic straightforward. So running this, it says the clock will again show 7 o'clock after 4k times, 4 times. It's alright. See you next one. Take care.